Welcome back, everyone. I'm here with Tudor Panu. Tudor is a software architect at Intel Corporation. And today he's going to explore the Eclipse MRAA and UPM projects and going to introduce the oneAPI beta. So Tudor, I will turn it over to you now. Thank you for being here.
Hello, everyone. And Karen, thanks for the introduction. I'm actually going to stop my video here so that we can go on and take a look at the slides I have prepared for today. Unfortunately, I think I'm getting some echo, and it's making it difficult for me to speak to the present day.
From where I am, Tudor, you sound good.
Okay. If that's the case, I'm gonna move on. Sorry about that short technical glitch. My name is Tudor Panu, and I'm a software architect for Intel Corporation. Today, I'm gonna be introducing you to the Intel oneAPI IoT Toolkit. This is currently in beta, and it was announced a couple of months ago. But it is a new product that is, in a way, a transition from something that a lot of you already know and use in terms of Intel System Studio. So my agenda for today includes the Eclipse MRAA and UPM projects. These are going to be the main topic, but I also want to show you how you can use these projects from System Studio as well as the IoT Toolkit. What are some of the new things with the projects? We actually did have a new release recently for the MRAA project, adding a couple of new things. So I'm going to talk about that. And in the second half, I'm going to introduce you a little bit or present a couple of other Intel tools that I think are very valuable for developers, such as the OpenVINO Toolkit, the Intel Developer Cloud, and a couple of things that you could use for some real-time and robotic applications. The reason I kind of like sneak that in there is because, as you probably know, I mean, today is a pretty big day, right? We have a great event going on, and I'm not talking only about the Eclipse Virtual IoT and Edge Native Day, but also a rocket launch from SpaceX, right? A manned mission that only shows, some amazing things and technologies and software really coming all together, and orchestration, like so many great minds just getting together to make such great things possible. So, with the MRAA and UPM projects, I can't really say that I would use them as they are directly to build things like that, right? I mean, it doesn't quite work like that. You have to combine them with many other technologies. You have to start somewhere, of course. So they're really great for getting started, with some basic applications, prototyping and building up things. But if you really want to go out there and develop and deploy in the real world and have some applications in industrial fields, transportation, retail, and so on, then you really have to combine the libraries with some of these additional technologies as well. So without further ado, the Eclipse MRAA and UPM, let's see where we are in a couple of project updates. So for those of you just joining us and kind of new to the projects, MRAA gives you user space access to pins and buses that you find on IoT platforms as well as newer edge platforms. So a lot of the times, these are exposed to the developer, and it's not easy to get to them. So this library provides an abstraction that, in the form of various classes, that not only allows you to access individual pins for general purpose IOs and analog inputs and digital outputs in the form of PWM, but also for buses, right? Some low-speed bus examples here include I2C, SPI, serial bus UART, so on. So these are all supported by the MRAA project And the nice part about it is that it offers an abstraction API, right? So this all looks the same. It doesn't matter if you're on an x86 platform, a MIPS IoT board, or an ARM platform, or some FPGA board as well. So it really doesn't matter. It all looks the same. Your application ports from one place to the other. One thing to note here is our 2.1 release. This was the first one under Eclipse Foundation. We do have some new boards added since the last update, the Eon Up Extreme. This is an edge IoT, or I should say an edge platform rather, but there are also a couple of IoT platforms that were added from ARM, such as the Raspberry Pi 4, Rock Pi 4, and Ultra 96. And these are all, just great examples of community collaboration. So the project spans well across Intel now, and we just have so many collaborators. The 80 Links Mark boards, actually, those are compute models. So what you can do is you can slot them into these modular microservers, right, that we started using at the edge, and you can customize them any way you want. So you can add, multiple compute modules. You can add volatile memory as well as persistent memory, like for instance in Intel Optane. And you can combine those, and you can mix and match any way you want. CPUs, accelerators, memory, you make it. Whatever you need for your application, you can build all that. So the architecture vision for MRAA and UPM really includes an abstraction that goes all the way to also give you sensors, actuators, and some interfaces to radio modules, as well as some utilities that allow you to work with some industrial protocols and legacy systems that have been used in the industry for a long time. So this is the vision. Unfortunately, we're not quite there yet. The part that we focus on the most right now is the sensors part up on the top left. So a lot of these are provided in the UPM library as abstract interfaces. And our next goal here is to really try and expand on these, but do it in a way that also accepts developer feedback. And this is what the project is asking for right now. We want as much feedback as we can get from our users for how to develop some of these new interfaces as well. Of course, go ahead and test the existing ones. For the existing ones, the goal is also to provide a way to virtualize them in a way that would allow application developers to simulate or emulate some of these sensors without actually having them connected to a system. So this allows you, to work on things like the front end, the user interface, and maybe, the client application without necessarily having access to the system itself. A little bit about the project dashboard. So both of these projects migrated fairly well to the Eclipse Foundation. A lot of the tools and the services that we were using to maintain them are still in place. For instance, we still run sonar scans all the time, showing us how we do in terms of static code analysis, where we are in terms of bugs, vulnerabilities for the projects. And we do have a couple of new ones here. That's why I think that this is an area where we want to take a look in the near future and see what we can improve. These are some things that were also communicated broadly to our edge partners. So the foundation is aware and actively working to resolve these things. As you know, one of the main goals is, in IoT is to keep it as secure as possible. So that's not really easy, and especially with memory constrained devices, there's not a lot of built-in security you can add. So you have to ensure that the libraries that run on these devices are as bulletproof as possible. A couple of other areas that I've highlighted here are our documentation. the generators and the host. This used to be hosted on an Intel website in the past, and it was automatically built whenever the projects were modified on GitHub. The documentation still exists and it's accessible. You can access the latest documentation that we have, and it describes how to use all the APIs and classes for C and C++ and all the other supported languages for the project. However, no new generation no new documentation is actively generated. This is due to, not because it wouldn't work, but because we actually need to figure out a new host and where to publish the documentation, since the projects are now under the Eclipse Foundation. Or the last thing here, release automation. This is something that kind of like was in place for various distribution channels that the project has. We've updated some of the documents to show you how to get these projects installed in the easiest way possible. And for a lot of operating systems, a lot of Linux flavors, we actually do have that available, so you can install them. But again, these are kind of like all these packages that you find with or the binary distributions of the projects are usually also community maintained, and that's done manually. What we would like to do is have some form of release automation that allows us to distribute binaries for some of these active operating systems in a fashion that allows our maintainers to focus more on developing the libraries and the code, and not as much how they get published in the infrastructure. So those are the updates for the MRAA and the UPM projects. I'm going to move on to Intel System Studio. The current product version is Intel System Studio 2020 Update 1. And this is actually an Eclipse CDT-based environment that integrates many Intel technologies. And they are split into three main areas: debug, analyze, and build. I'm not going to talk about them in that particular order. I'm going to start with the build section here, because I think this is where an application developer, especially ones that are trying to develop a new application, would start. So Intel System Studio brings you not only the Intel compilers, but also a lot of libraries, right? That allow you to extract the best performance on Intel architectures. And not only, you'd be surprised that some of these libraries actually are the best in class for when it comes to some of the algorithms that they make available for you. So part of the process, of course, after you do build your application, you want to start debugging it. Nobody's perfect, so as we develop, we all make mistakes. We have to go back and understand why is that happening, or why is an application not building correctly or crashing during runtime. And that's how you figure this out. Once you get your application in shape and it starts running and it does what you want it to do, that's when you actually get to the final phase of it, and you start analyzing the performance of your application and fine-tuning it, right? So in Intel System Studio, you had all these technologies bundled together in a way, and easy access to them, so you could really go through the entire flow in the whole process. So you could build end-to-end application, from day one, and even an idea, you could take it all the way on a production system and deploy it continuously to your customer. So as I said, this is all based on Eclipse CDT, but it also has a lot of IoT, and I should say edge-specific features. One of them is the integration of sensors and actuators from the Eclipse UPM project. And these are very easy to use with applications that you develop in Intel System Studio. The typical flow that we've seen is that developers usually start from an existing sample, so a basic code sample, and then they open up the sensor support window, browse through some of the available sensors in order to find the ones that they usually get from, say, an IoT kit, and then they start experimenting with them. Now, of course, there are many examples and links to vendor pages and images of the sensors and other things in here. And once you find the sensor you like, all you got to do is click on a checkbox next to it, and it will get added to the project automatically. Now, that all sounds good and really smooth, but unfortunately, it's also a pretty big maintenance burden. And there's a lot of code behind it, making that interaction possible between the project and this view. And a lot of elements that need to be maintained, some code that was developed, by engineers who may be no longer with the company or work in different areas now. So what we wanted to do was try to see if there's a different approach to this. The typical flow here, before I get into that, just to finish on the current idea, is once you do add the sensors, you can run your application locally. Of course, there's nothing stopping you from doing that, and that's usually the case if you have an IoT or an edge developer kit, but you can also run it remotely, and that tends to be typically the use case for this. You develop on your own, personal computer or a laptop, and you can use a custom image, say take a Docker file with your favorite base OS, you customize that, you add all the libraries and dependencies that you need to it, and then you can basically build your application against it and run it remotely. So all that comes in Intel System Studio, and in a way it transitions to the oneAPI IoT Toolkit. Now, the IoT Toolkit, and I've linked it here, the main program site is software.intel.com oneAPI, and you'll find a link to the other toolkits from here. But really, what we're trying to do here is approach things a little bit differently and meet developers where they are. You'll see here that some of the things included have stayed the same. So you still get the Eclipse IDE, you still get the IoT connection tools. There are some small variations there. The Linux kernel build tools, and these are all the items on the right, are used by developers to target Yocto project and compatible targets. So you may know some of those, but also some of the Intel tools included on the left. The C++ compiler, which is really essential because you get a good performance boost just by switching to that compiler on an IA platform. The Intel Inspector as well, which allows you to do some early detection of errors in your designs, and the System Debugger, which of course allows you to do extensive debugging, not beyond application level, and debug system registers and lower level architectural elements that might be affecting the performance of your application. So summarizing all these, and I'm getting a question, they are all free to use. The Intel oneAPI Toolkit Beta is actually also an effort to open source some of these tools. So a lot of the Intel libraries used to be proprietary. Under the oneAPI program, you'll see that you'll be able to access them more easily. Not only they're free to use, but as I was saying, we're trying to meet developers where they are. So what that means is that you can get the oneAPI Toolkit now through native distribution channels. So, to me personally, this is a really big change. With Intel System Studio, you had to go to a website and register, and at least back in the early days, and it took a while, right, to get to the tools. It wasn't as easy. With this, you can simply do, if you're, let's say, on an Ubuntu system, you can do apt install oneAPI IoT toolkit after you add a public key to validate it, and it's as easy as that. You get all these tools. What you also get is an updated version of the sensor support window. We called it Sensor Browser. This was redone from scratch in a way that is open for Eclipse developers to contribute to it as well. And as a matter of fact, it was based on some Eclipse templates that originate from some of the earlier project days and were in turn used by developers to extensively to develop Eclipse plugins. So the way you get to this is from the window menu. When you open other views, now there's a new IoT section in here, and you have the sensor browser in there. So I really hope that this becomes a standard feature of Eclipse ADT now, as you can see, it looks different, right? So instead of having a grid format, we now have more of a folder and a file style browsing experience that also offers a search function. So it allows you to easily go and find that one sensor you need for the project. And once you do, it will just give you some brief details about how to add it to the project. It's not automated anymore, but it's very easy to just contextually add it to the file that you have open. For instance, I'm showing you right now a hello IoT example that also uses the C++ compiler. So you can easily add the sensors here, and like I was saying, all of this is still in beta, right? So this is your chance to give us some feedback and tell us what other elements you want to see here. Of course, the one element that's missing now is a link to the actual sensor page where you'll find the sensor examples. And the reason we switched to this format is because we want the UPM project site or website to be something that OEMs and ODMs use as a template. So really all the interaction with the sensors, the examples, the images of the sensors, the specifications and everything else can be done through that template site that others can then customize and take and show to their own customers with their own styles and in their own company brand. So moving on, I'm going to start going through some of the summary slides. And what I mean by this is a couple of slides that show links to a couple of additional tools that are very interesting for IoT and edge application development. One of them is the OpenVINO Toolkit, as you know. This allows you to do computer vision and inferencing for edge systems. And it consists of a couple of elements that are widely used in our applications. And, we've seen them in previous presentations, but really these are the inference engine and the model optimizer, the ones that are being used the most, or at least this is the image that you probably remember from last time we met. However, there are some new things in OpenVINO that I would like to invite you to check out. And since the current version for the product is OpenVINO 2020.2, and the new feature I was telling you about is the deep learning workbench, which allows you to simulate the performance of your models before you actually deploy them, and you can simulate it for various architectures, so like CPUs, GPUs, accelerators, and such. And you can also tweak the precision of the models, right? So you can change from a floating point to say FP32 to int8 to reduce the precision of a model. You can make inferencing a lot faster by doing that. And in some applications, actually, you'll be amazed in a lot of applications, you can get away with that reduced precision without really affecting the overall usability of your application. One of the other things, or I should say one of the other new things in OpenVINO would be the model server. You can find this on GitHub. That's the second link down there. It's one of the projects. I actually think this is an interesting one because it offers a scalable inference server that you could say run on various edge devices, and that also uses a REST API. So think of it this way: you can build a cloud of edge devices, or let's not say it that way. You can build a network of edge devices, and then essentially send an inferencing task to the right edge device based on this model server, and by doing a little bit of extra work to just determine what layers you can run on the specific devices. The next slide is on the Intel Developer Cloud. I've linked this here as well. The way I think about the Intel Developer Cloud is a cloud-hosted solution for application developers that allows you to try all these tools that I was mentioning before you actually buy them, right? So another way to think about it is think of the expensive FPGA cards, right? Or think of some of the higher end Xeon systems, right? They tend to be pretty expensive, and you can't always, get them right away. You might want to determine whether your application is running well on that platform or not at first. So the Dev Cloud allows you to do that. It allows you to queue your application, or you can bring your own code. You can build it and run it on the Developer Cloud, and you can pick between various Intel hardware platforms that are available, and these include all of the accelerators that are available, as well as others. One last thing to mention about the Dev Cloud is there are various flavors of it, if you will, based on the kind of workload or the application you're trying to develop. I think for Edge native, there's actually a dedicated Edge and Dev Cloud. So I invite you to use or check out that one, sign up for that one. That has the tools I was mentioning throughout the presentation. And in closing, I would like to just quickly mention the real-time needs of the edge. This is actually some new technology. I'm just going to leave you with the links here because there's not much time left. So I also wanted to see if we can get into some questions. This is maybe something that like a topic for the future, if you will. I guess maybe this is something that we can come back to in later in the year, in August or September, at the next event.
Great. Thank you so much, Tudor. Does anybody have any questions? We have about a minute left before we have to wrap up. Everyone will be able to see all of Tudor's links that he mentioned if they want to replay the crowdcast. And that'll be available forever, and then we'll upload it to YouTube as well. Great job. Sounds like a lot of work has gone into these projects and continues to. A lot to summarize in 30 minutes. I appreciate it.
Yeah, really a lot to talk about. And Karen, thanks a lot for having me here. Thanks everyone for joining.
Thank you so much. Bye now.
Bye.